Okay. So let's begin with number 3, covering section 8.2. A real estate agent wishes to determine whether tax assessors and real estate appraisers agree on the value of homes. A random sample of the two groups appraised 10 homes. Is there a significant difference in the values of the homes for each group? Let alpha equal 0.05. Assume the data are from normally distributed populations and that the population variances are not equal. Okay, guys, I need you to tell me what would be the null and the alternative. The question is there significant difference in the values of the homes for each group? Let's assume U1 represents the population mean of the tax assessors' values and mu2 the real estate appraisers' values. All right, so that's number 3. And what is it gonna be, guys? Okay, I got a response. You can respond to all if you like, yeah. That is correct, equal and not equal, because it says difference. Difference means not equal. And that's the claim. Okay, let me write down the given information that we have here, and then I can. So we have X1 bar, so we'll go to the calculator. It's a 2-sample t-test. How do you know, guys? Look, he gives you S1 and he gives you S2. When he gives you sample standard deviation, and the other hand is telling you a population variances are not equal. That means there is a pooled option here, which is you have to choose no when when variances are not equal. So we're gonna use 2-sample t-test. And let me show you how to do this. Okay, we'll turn the calculator on. And I am in 2-sample. Let me just show you back how to go to t-tests. 2-sample t-test. Not data, it's X1 bar, okay, which is 83,256. S1, 3,256. N1 is 10. X2 bar, let me just get the data now from X2 bar, 88,354. And then S2 is 2,341. And N2 is 10. And you guys agree that the alternative hypothesis is not equal to. And now he says here, population variances are not equal. That means when it comes to pooled, you have to select no. You have to select it and press enter. And now I want to show you the screen one more time before I hit enter. Okay, don't worry about that. And if you hit calculate, there you go, guys. T is negative 4.020 and P is 9.52401, E negative 4. So I'm going to write them down and then we interpret the values. So I'm just going to put here pooled is no, just for your information when you review this one. T turned out to be negative 4.020 and P value. Can I notice on the assignment, some of you did not pay attention to E. You cannot ignore the E, guys. Okay, the E negative 4 means you have to move the decimal point 4 digits to the left. So actually your P value is almost 0. It's 0.000952, which is almost 0. You can make this assumption always. And this is less than alpha. So we reject HO. what would be the conclusion? He says, can you check if they are different? So question 3, let me show you one more time. Is there significant difference in the values of the homes for each group? So there is enough evidence at the 0.05 level of significance to support the claim that there is significant difference in the values of the homes for each group. I'm just going to write it down. That there is a significant difference in the values of the home for the two groups. Any questions, guys? Number 4. What does number 4 say? Researcher suggests that male nurses earn more than female nurses. A survey of 14 male nurses and 22 female nurses report this data. Is there enough evidence to support the claim that male nurses earn more than female nurses? Use alpha equals 0.05. Assume that the data are from normally distributed population. He has to tell you that the population are normal because the sample sizes are less than 30. And that the population variances are not equal. That means the pooled is no. When you use pooled is no. So I'm gonna just bring a blank page for this question. And I just wanna bring one thing to your attention, that here he put females first. So he wants you to label females as number 1. So let's see, guys, how we're going to state the null and the alternative hypothesis. So remember, mu1 is for females and mu2 for males. He put that, so you cannot change that. I know if you were reading it and there are no label, you would have done 1 for males and 2 for females because he started with male first. How we're going to state the null and the alternative hypothesis here. I'm gonna set it up. I'm just gonna put mu1 and mu2. You see the nice thing about this, no numbers, you just put the signs. Okay, who can tell us what are the signs here? Okay, if males are making more than females, then I'm gonna write this statement and tell me if you agree with it. Then females are making less than males. Do you guys agree with this statement? Exactly. Yeah. So now I see that someone sent that. So guys, I know you were going to put greater than because it says more than, but it says males. And unfortunately here in this question, he decided to trick you a little bit and label females as number 1. So if males are making more than females, guys, that means females are making, the claim is females are making less than males. So that should be a less than, and that should be a greater than or equal to. Otherwise, if males were written first, you guys just do more than as usual as you do. But this one is different because he labeled the females first. You cannot change that. So when I claim I make more than you, then you guys make less than me. That's how it works if you start with you first. And that's what it is right here. Okay, it's a 2-sample t-test. Let's do the test together. Okay, let's go there. Stat, tests, 2-sample t-test, and let's do it. All right, it's a summary. X1 bar. X1 bar is for the females, 23,750. Be very careful as you enter your data. S1 is 250. Now, N1, what did he say? How many females? A survey for 14 male and 22 females, so 22. X2 bar is 23,900. S2 is 300. And how many males? A survey of 14 male, so it's 14. We're testing that the females make less than males, which is the same as testing the males make more than females. And you guys, you should agree that population variances are not equal. It's a no. There you go. Calculate and enter. So T is negative 1.558. I'll write it down. And p-value, as you can see, guys, 0.0661. Okay, and what's alpha here? 5%. So can you guys tell me what sign do I put here? Is p-value more than alpha or less than alpha? Yep, more than alpha. So fail to reject, I agree. Always say fail to reject what? So fail to reject HO. And then you guys, oh, we forgot to label the claim right here. So there is not enough evidence at the 0.05 level of significance to support the claim that male nurses are making more than female nurses. All right, so that concludes the question. And before I move to something new, guys, I just want to bring your attention to something you might see in the problem. Okay, so note here. If he says population variances are equal, we say we use pooled, yes. And if he says population variances are not equal, we use pooled, no. But sometimes, guys, he doesn't say the word population variances are equal. It just instead in the book says this. Sigma 1 is population variance, population standard deviation. When you raise it to the second power, it will become population variances. So if you see something like that, guys, it's the same thing. Population variances are equal. You use yes. And there are times where he doesn't write, the words. He doesn't do it in words. And just get this. Sigma 1 squared not equal to sigma 2 squared. So if you guys see this, it's exactly the same as that. Population variances are not equal. You use no. Okay, so that is everything about section 8.2, where we test the difference between two means. We use the two sample t-test when he gives you the sample standard deviation S1 and S2. Now, one more thing, guys, I'd like to tell you about this section before we move on. Stat test. Let me show you something here. We haven't used data here yet. I might just come up with a problem later, but if he gives you, just data values, a raw data set from two different samples, sample 1 and sample 2, you use data and see what happens here when you use data. It will tell you where did you put, the data from the first sample, where did you put the data from the second sample. You do not change the frequencies, guys. Leave them alone. You choose mu1 or not equal to, less than or greater to pooled, and then you just do the same work. So actually it's even easier, just when he gives you a raw data set. But none of the problems we did have a raw data set. It's all summary. I'll make up an exercise later to do that. And actually, one of the exercises that I worked out has one with the data sets. All right, the next section we're gonna do, guys, is section 8.4, and then we'll go back to 8.3. So I'm gonna go to 8.4 right now. Here you go. So just 1 second. If you have the handout, it's on page 7, the 7th page, and this is section 8.4. So let me just label that. Why I'm doing 8.4 before 8.3, because section 1, 2, and 4 are about independent samples, and this is also independent samples. But here we're testing the difference not between two means, it's between two proportions, P1 and P2. So no more means. We did the means in section 1 and 2. Now we're going to do the proportions. And you're going to find it very much, just the same. You will see when we do a problem. These are the conditions of the test. He has to tell you that the samples are random. So they're done randomly. The samples are independent. As I told you, the first two sections and the last section of chapter 8 require that the samples be independent. That means one sample is not related to the other. The samples must be large enough to use a normal sampling distribution. That means N1, P1 greater than 5. I'll demonstrate this condition in a little bit. And in this case, we use two sample proportion test for the difference between two proportions. So the name of the test is this, 2-prop Z test. You will see that in a second. So in order to solve a problem with two proportions, we have to verify that those conditions are met. Then we have to state HO and HA, calculate the test statistic Z, calculate the p-value, make a decision to reject or fail to reject HO, and then interpret the decision in the context of the original claim. Nothing new, guys. You've done already those 5 steps. What I would like you to do is to write the 3 ways to state the null in the alternative hypothesis right here. And I'm going to give you a minute. Use P1 for the proportion from population 1 and P2 for proportion from population 2. So let's do that. Let's write them down. You can start. I'm going to start with equal, not equal. That's 1. Or P1 greater than or equal to P2. P1 is less than P2. That's a second option. And there's an HA here. I forgot to put that, or maybe I left it blank intentionally. P1 is less than or equal to P2. P1 is greater than P2. So you guys, you already did the first step for you. All you have to do is just figure out which one to use. Always in section 8.4, you have to start with one of those, either the first one, the second, or the third. Now you tell me which one. It depends on the problem, what he asks you to do. Okay, let's do a problem and show you how to do it. There's an exercise. In a study of 150 randomly selected occupants in passenger cars and 200 randomly selected occupants and pickup trucks. So we have two population, guys: passenger cars and pickup truck. Okay, since I started with passenger cars first, I'm gonna call it N1 here for passenger. It says 150. And 200 pickup trucks, so N2 will be 200. Everything is labeled 1 and 2 in chapter 8, guys, because you're doing two sets. In chapter 7, we had only one N, but here we have two of them. 86% of occupants of passenger cars and 74% of occupants in pickup trucks wear seat belts. So this is an 86%, and I want someone to tell me what this one is, and 74% in pickup wear seat belts. At alpha equals 0.10, can you reject the claim that the proportion of occupants who wear seat belts is the same for passenger cars and pickup trucks? Before we continue, guys, to the next step 2, I'd like you to tell me what do you think step 1 is going to be. Is it going to be the first one, the second one, or the third one? He says, can you reject the claim that the proportion of occupants who wear seat belts is the same for cars and trucks? So first, second, or third, guys? Yep, it is the first indeed. Here you go. And they are the same, so the claim, oh, this time the claim is in the null hypothesis. Because some students were asking me, we don't see the claim in the null hypothesis. Well, it could happen, and it is in this case. Okay. We still have to figure out what we're going to do with this. Before we do that, I'm going to show you the test, guys, and maybe you can tell me what to do with this. Your test is two proportion Z test. Oh, it's asking for X1, N1, X2, N2, etc. So, what is 86% here? 86%, guys, is a p hat. It's a proportion from the sample. Sometimes he gives you N1 and X1, but other times he doesn't give you X1 directly. He gives you the proportion, which is a P1 hat. And this is a P2 hat. And do you still remember how to find X from the previous chapter? I did show you how to find X. In order to find X, which is X1 here, you take 86%, guys, and multiply by 150. So this is 0.86 times 150. And for X2 bar, well, sorry, X2, it would be 0.74 times 200. So here, let's just do it. 0.86 times 150, guys, it will be 129. and this one will be 148. Now I have to tell you something. If x1 and x2 turn out to be decimals, you must round them to the nearest whole number, because these are number of successes. And you cannot have, they have to be a whole number. So if you get a decimal, let's say here you got 129.7, make it 130 when you enter it into your calculator. So let's do this exercise. All right, you're ready? So it's a 2-sample proportion z-test. 2-prop z-test. Anytime with working with 2 proportions, this is the only test, guys. No confusion here. So just 2-prop z-test. I'll take you to the test right now. Stat, tests, 2-prop z-test, and x1 first, which is 129. N1 is 150. X2, 148. N2, 200. We're testing that P1 is not equal to P2 for the alternative hypothesis, and hit calculate, guys, and that's all. So watch, Z is 2.73 and p-value is 0.0062. I'll just write them down. And I'm done with the calculator. I don't need the calculator anymore. So alpha is 10%, guys. You guys agree with me that this is less than alpha? So what's the decision here? If p-value is less than alpha, you must reject the null hypothesis. Okay, now I want a student to tell me what's the conclusion. Remember, the claim this time is in the null hypothesis. What do we say? And we rejected the null hypothesis. Yep, there is enough evidence to reject the claim. There is enough evidence at the 0.10 level of significance to reject the claim. Again, for students who are wondering why don't we say the word support. Look, guys, the claim is in the null and you reject the null. Well, if you reject the null and the claim is a part of it, you reject the claim because it's part of it. It is the null hypothesis, so you reject the claim. To reject the claim that the proportion of occupants who wear, I'm just copying and pasting from the question itself. Seat belts is the same. Is the same for passenger cars and trucks. We're saying here, guys, that no, it's not the same proportion of people who drive cars and trucks that wear the seat belt. And I can tell you this is true, guys, because people usually who drive pickup trucks, because their big cars, are more inclined not to wear the seat belt because they feel safer than if they were in a car. Whereas people who are in small cars tend to wear the seat belt more often than pickup trucks. Because they will be worried, you know, just if they get into an accident. So it's usually, it's not the same. When you feel safe in a big car, probably you'll be inclined not to wear the seat belt. If it's not against the law not to wear it. All right, so this is the first question. We're gonna do another question together. There you go. That's one more. Let me just get it ready. Let's do this one together. A medical research team conducted a study to test the effectiveness of a cholesterol-reducing medication. At the end of the study, the researchers found that of the 4,700 randomly selected subjects who took the medication, 301 died of heart disease. Of the 4,300 randomly selected subjects who took a placebo, sugar pill, 357 died of heart disease. At alpha equals 0.01, can you conclude that the death rate due to heart disease is lower for those who took the medication than the ones who took the placebo? And adapted from the New England Journal of Medicine. So, medication, and then placebo. We have N1, X1, and we have, he gave you N1 and X1 here, no N2 and X2. So it's very straightforward. What is N1? How many in the sample who took the medication, guys? You agree, 4,700? Yes. $300 of them died. So it's 301. So the X1 is 301. And let's see the second one. The ones who took placebo, sugar pill, 4,300. And X2 is 357. So we're using P1 for people who took the medication and P2 for the placebo. What would step 1 be, guys? The null hypothesis. Let me show you and tell me which one. The question is, can you conclude that the death rate due to heart disease is lower for those who took the medication than the placebo? So the medication is lower than the placebo. Which one would that be? First, second, or third? I agree. I heard the second, and that is correct. We want to check that the proportion of death from the ones who took medication is lower than proportion of death from the one who took placebo. So we want to check if P1 is less than P2. I agree. And this is the kind of research they're doing right now, guys, to come up with a cure or a vaccine for COVID-19. This is what the scientists, just have been asking for, to do controlled group studies. They bring, in two groups. One group will get the medication, another group, will get nothing, and then they compare, the effectiveness of the medicine. So HA, P1 is less than P2. That's the claim. And here P1 is greater than or equal to P2. Okay, 2 prop Z test, guys. The name of the test is 2 proportion Z test. In chapter 7, it was 1 proportion Z test. Now it is 2 because you have 2 samples. So let's do this. Stat, tests, proportion Z test. Sorry, 2. All right, X1. He wants X1. I know, guys, it's tempting to put 4,700 to begin with, but no, be careful. He wants X1 first, so it's the smaller number, 301. N1, 4,700. X2, 357. N2, 4,300. P1 is less than P2. All right. And then Calculate. Here you go. Z is negative 3.4. Two decimal places, it will be negative 3.46. And the p-value, look, there is an e negative 4. Please do not ignore it here. There is an e negative 4. So let me write them down. I'll write it down first. 2.7503. And I'll interpret this. That means, guys, you have to move this decimal 4 decimal places this way. So that will be 0.000275. It's almost safe, guys, to say it's less than, it's almost 0. So your p-value for sure is less than alpha. We reject HO, the null hypothesis. And then step 5. What do we do with step 5? We write a conclusion. The claim is in the alternative, and you reject the null hypothesis, then you support the claim. As simple as that. So there is enough evidence at the 0.01 level of significance to support the claim, or conclude. You can use the word conclude because he says conclude, but that's okay. That death rate, see guys, I'm just copying this now. Death rate due to heart disease is lower for those who took the medication than for those who took placebo. All right, so that's how we perform the two proportion z-test for the difference between two population proportions, P1 and P2. Let me tell you about this test. This is a very important section. It's unique because the samples are dependent. Let me give you an example of dependent samples first. I take 20 students. I measure their heartbeat rate before they take a test. And then again, I take the same 20 students and I measure their heartbeat per minute rate while taking the test. These samples are dependent because they are referring to the same students. Or here's another example. We take 15 students and we check, their test 1 score. And then those same 15 students will go through a test preparation seminar. And then they take the second test and will take their scores again. It's the same students. These two samples are dependent. So when it relates one person from one sample to another, in this case, the samples are dependent. But independent samples, guys, as we did before, for example, the salaries of 15 male workers at a factory, and then another sample will be the salaries of 20 female workers at a different factories. These are independent samples. So So there is a big difference between dependent and independent. What you need to know, guys, that this section 8.3 deal with dependent samples. I'm going to show you these examples right away before I start talking about it in that chapter. So to tell me if you think that these are dependent. Okay. A shoe manufacturer claims that the athletes can increase their vertical jump heights using their manufacturer training shoes. So a manufacturer is claiming that if an athlete wear their training shoes, they can jump vertically a lot higher than if they were wearing some other shoes. The vertical jump heights of 8 randomly selected athletes are measured. So these are the vertical jump of 8 athletes are measured. After the athletes have used the training shoes for 8 months, their vertical jump heights are measured again. So these are the new measurements, guys. And this is the same person here. Before they put on the new shoes, and this is after. Before and after, before and after, before and after, and so on and so forth. And these are the people. So would you guys agree that these two samples are dependent? Does that make sense to say that they are dependent? So if you want a hint, guys, how do you know if the two samples are dependent? When you see a table like this, an action before and an action after, be assured that the samples are dependent. And every single exercise in chapter 8, section 3 are like that. They show you this table. Sometimes they put before and after. Here it's old and new. So an action before and an action after for the same person. This is athlete number 1. This is John. This is Mark, etc. So these are the same athlete before and after. So you need to understand what dependent samples are. Okay. Here's how we're going to test the hypothesis. I'm going to start with this example, and then I'll go back to the page and fill in some blanks in there. I would like you, first of all, guys, to work with me and do the difference for me between the old vertical jump and the new vertical jump. So the first one minus the second one. Can you do the differences? 24 minus 26. That will be what? A -2. What's 22 minus 25? A -3. What's 25 minus 25? 0. 28 minus 29, -1. You can use your calculator, you want to do that. 35 minus 33 is 2. 32 minus 34 is -2. 30 minus 35 is -5. And 27 minus 30 is -3. And I'd like you to pay very good attention here. Actually, we have two samples, guys, here, but in the case of dependent samples, once we do the difference, we will not work with two samples anymore. We will be working only with one sample, which is the difference. And I'll show you how we're going to proceed with the difference. Let me ask you a question. If the manufacturer claim is right, so that means athletes will increase their vertical jump heights when they wear the new shoes, what do you expect the difference to be? Positive, negative, or equal to 0? So an athlete, if it works, an athlete was doing 24 inches before, and now the athlete is doing 30 inches. Or if an athlete was doing 15 inches before, when they wear the new shoes, they're going to do 20 inches. So 15 minus 20 is -5. Or an athlete was doing 28 inches and now it's doing 30 because it did improve. 28 minus 30 is negative. So let me see what students are saying here. It is increasing. Well, if it is increasing, what do you expect the difference to be? I know this is a little bit confusing here. Yes, I agree. It's increasing. But when something increases, let's say it goes from 7 to 10, what's the difference, guys? Is it positive or negative? I want you to agree it's negative. It's the total opposite. Yes. So an increase means the difference is negative. Watch. Let me give you another example. If I'm making, $10 an hour now, and then eventually later they're going to increase, just my wages to $12. What's the difference, 10 minus 12, guys? Is it positive or negative? Do you guys agree that it is negative? It's negative too, exactly. So that means, I know when I say increase, guys, in your mind, you put the word positive. No, increase, when you do a difference, it means the difference is negative. Does that make sense? Like I'm making 1,000 today, and next week I'm going to get an increase. So my new salary will be 1,300. If you do 1,000 minus 1,300, it's a negative 300. So the difference will be negative when you subtract the first set minus the second set. So here's how, so it's less than zero. So here's how we're going to state the null and the alternative hypothesis when you do dependent samples, guys. Let me state the three hypotheses. So we do the difference of the two sets, and we're going to test against zero, whether it is positive or negative. So here's how you state the null and the alternative hypothesis. Watch, guys. It's one mean because we're doing the difference, and they label it in the book as D, so it's mean from the difference. It's either equal to zero, not equal to zero, that's one, or the mean of the difference is greater than or equal to zero, less than zero, or mu of D less than or equal to zero and greater than zero. It's one of those three, guys. You have to select one of them. It's always against zero. When you do dependent samples, you are testing the difference against zero. All you have to decide, is it the first one, the second one, or the third one? The hint, guys, an increase means you have to look for this. A decrease, you have to look for that. And let me tell you why positive for the decrease. Here's an example. I was making $10 an hour, and because just of what's going on right now, salary is going to decrease to $8 per hour. What is 10 minus 8, guys? Do you guys agree with me that 10 minus 8 is $2? It's a positive. So when you talk about decrease, the difference will become positive. So that's very, very important, just to pay attention to this. So, and the mu sub D means mean of the difference, mean of the difference, mean of the difference, etc. So let me go back to my exercise and put the first step, HO, HA, mean of the difference, mean of the difference. And you guys, you agree with me that since the claim is the vertical jumps is going to increase, so we're going to test that mu D is less than zero. That's the claim. And mu D greater than or equal to zero. And did you notice, guys, that most of the numbers are negative here? That means that probably we're going to be able to support the claim because the differences are negative. Here it's working. Here it's working. The athlete is increasing his vertical jump by 3. Here it didn't make a difference. Here it's working from 28 to 29. Here, no, this guy is doing worse actually with the new shoes. Here it is working. It is working. It is working. Now the question is it working in general? That's why we need to perform the hypothesis test. And here's how you perform the test. You're going to be surprised. Now we have to go back to chapter 7 because it's only one set. We will be doing a t-test against this set right here. So we're done with this. No more old, no more new. We're just doing this one. So here's the first step. The first step is to put this one in L1. So I'm going to go and put the differences in L1. Stat, edit, and I'm gonna go to L1. Let me clear it for you guys. Let me clear the other set so you don't get distracted here. L1, -2, -3, 0, -1, 2, -2, -2, no, -5 here, and finally -3. There you go. I got him right here. So this is the next step, guys. You do the differences and put them in L1. And let me show you the test. You go to Stat, Calc, Tests. You don't, Stat, Calc, Tests. You don't choose a 2-sample z-test or 2-sample t-test because we reduce that to one set, which is the difference, so it's a t-test. It's always a t-test. And data, it's always data because you have raw data here. And you guys, you're testing against which value? It's always against the value 0. So I can tell you guys for this section, be assured that it's gonna be 0 always here. My list is in L1, so I'm gonna change this one to L1. Okay, and what is the alternative sign here? Less than, correct? So I'm just gonna put less than. And here you go. T is -2.333 and p-value is 0.0262. So let me write them down. Here you go. And now guys, what is alpha in the exercise? Alpha is 0.10. So can a student tell me what's the decision in step number 4? You guys agree with me that this p-value is less than alpha? So we what? Reject HO. And conclusion. My claim is in HA, I support the claim. There is enough evidence at the 0.10 level of significance to support the manufacturer claim. And then write it down, guys. To support that athletes can increase their vertical jump heights using the manufacturer training shoes. 9 students took the sets. Their scores are listed below. Later on, they took a test preparation course and retook the set. First of all, guys, do you agree that this is, these are dependent samples because it is the same students who took the set before training course and took the set SAT after the course. So it's the same students, number 1, number 2, number 3, etc. Okay. Test the claim that the test preparation had no effect on their scores. Let's do the difference here. So we're gonna do the difference. What does it mean had no effect, guys? Do you agree that no effect means the difference is 0, no difference at all? So it will be mu of D equal to 0. This is the claim, it didn't make any difference. And the mu of D is different from 0. So again, it's against 0. What we did here, what I did, first of all, I did the difference. So I put D here and I did 720 minus 740. It's negative 20 right here. And then 860 minus 860, guys, is 0. And then 850 minus 840 is 10. 880 minus 920 is negative 40. 860 minus 890 is negative 30. 710 minus 720 is negative 10. 850 minus 840 is 10. And then 1200 minus 1240 it's negative 40. And then 950 minus 970 is negative 20. And then we will go and input this into the calculator. So what I'm going to do, I'm just going to put this into your calculator. Stat, edit, enter. I'm just going to clear L1 and enter those values again, guys. So negative 20. That's the first one. 0, 10, negative 40, negative 30, negative 10, 10, negative 40, and then negative 20. There you go. These are the values. Then you go to your calculator, stat, tests, t-test, and data. Definitely, it's always data here, guys. Again, 0. Leave this blank here to just at default 0. I put my differences in L1. Don't change the frequency. And now the alternative is not equal. And then calculate. So I got T to be negative 4, negative 2.400, and the p-value is 0.043 to show you that this is what we got here. And p-value is 0.043, which is less than alpha. Therefore, we reject HO. Okay, you reject HO and the claim happened to be in HO, so then you reject the claim. There is sufficient evidence to reject the claim. And these are the screenshots, guys. So that's where I put in L1. Then we went to t-test. Then we went to data. It's always against 0. And these are the output, the test statistic T, and the p-value. And then we got the p-value, which is right here, which is less than alpha. We end up rejecting HO. So this is another example pertaining to section 8.3. I'm going to give you a summary in how to state the null and the alternative hypothesis given some keywords. So that should help you a little if I just give you some keywords right here. I'll do that in a second, and that should be. So let's see. A physical education director claims by taking a special vitamin, a weightlifter can increase his strength. Okay. You should know already, guys, what the null and the alternative. I was talking about it. 8 athletes are selected and given a test strength. Uses the standard bench press. After 2 weeks of regular training supplemented with vitamin, they are tested again. So this is before and after. And I'm going to put the difference here. Now, maybe you'll tell me we see horizontal tables. Well, this time I just put a vertical. It doesn't matter. It shouldn't make any difference, guys. Test the effectiveness of the vitamin regimen at alpha equals 0.05. Each value in the data represents the maximum number of pounds the athlete can bench press. Assume the variable is approximately normally distributed. So the claim, a weightlifter can increase his strength. So would you guys agree with me that we want to test the difference, that the mean of the difference increase means the numbers were small and they're becoming larger. That's what an increase, that means the difference is going to be, can someone shout it at us? What would that be, the word, the sign? Yes, less than 0. Claim, exactly. Just talk about it, guys. Stick to this handout. See, the word increase means less than 0. That's it. Still hard to absorb? Send me an email, guys. I'll send you more explanation. No more, no problem. Okay, so less than 0. Now you guys, you have to do the differences. 210 minus 219 is negative 9. 230 minus 236 is negative 6. 182 minus 179 is 3. So this guy, he didn't benefit. Actually, it's lower with the vitamin. 205 minus 204, again, this guy, it didn't work for him. 262 goes up to 270, it worked for this guy. You see, when it works, when there is an increase, you see, guys, we're getting a different negative. So that's why I'm testing less than 0. 253 minus 250 is 3. 219 minus 222 is negative 3. And that's 0, no difference. And you know what we're going to do. We're going to go to the calculator. And we're going to go to stat, edit first. You won't have a data set with more than 10 entries in the book, because so it's not much data entry, as you can see. And guys, I want to bring to your attention, when you enter a negative number, you use this sign. This is a minus operation. This is a negative sign that you have to use. So negative 9, negative 6, 3, 1, negative 8, 3, negative 3, and 0. And now I go to stat, tests, t-test, data, against 0 always. L1, I put my data in L1. All you need, guys, to figure out the alternative hypothesis sign, which is less than 0. So just do less than. And I got t to be negative 1.388. And p-value, as you can see, guys, 0.1038. So write them down. T-test. All right. So you guys agree with me that alpha is 0.05. So this is bigger than alpha. Fail to reject HO. And the conclusion, there is not enough evidence at the 0.05 level of significance to support the claim that a weightlifter can increase his strength by taking a special vitamin. Although it worked for some, but it didn't work for everybody. But in general, it doesn't work. We cannot support it. So